So boys, we're going to go through this question where we find the value of a pronumeral and give the reasons. Okay, so if we look at this first question, I've just started to answer this one. It says m equals, and I'm going to say it equals 123 degrees because these actually look equal to each other. So I'm going to just guess it and say it is. But let's just turn it into something that's not a guess now and think about why they are the same. So this shape shows you that the opposite sides are parallel. So we know that this is a parallelogram. Now, if you look back at your table and look at what we discovered about the parallelogram and use your own common sense, these are the opposite angles in a parallelogram and they are equal to each other. So we're going to write that down for our reason. I could say opposite angles in a parallelogram. I'm just going to leave the word a up. Doesn't make much difference to our marking. So opposite angles in parallelogram are equal. Here's your opposite angles. They're in a parallelogram and they are equal. So that's the answer to the question. Okay, the next one, B. So this time, if we look at the shape, it's got 4 equal sides. So it could be a rhombus, but they put a little right angle in there just to straighten it up and tell you that it's actually a square. So we're looking at a square and thinking about the table that you've done and all the different properties that happen with a square. So we somehow need to get x out. Well, what I'm going to do is just get my red pen and mark this angle here. I'm going to call it something but not call it x. So let's call it A. And I'm going to find out what A is first. Right? So if you think about this, this is a square and we know that the square has all right angles in it. So we could say that A equals 90 degrees because all angles in the square are right angles. That's the reason. That's why you know that. Okay, so I'm going to mark that 90 degrees in near that A in red so I can see what I'm doing now. Or you could use a little red square for a right angle. Okay, so now we're looking at finding x. Now you could probably guess this. We're going to split this right angle into 2 equal parts because these 2 bits are equal. So we're going to do 90 degrees divided by 2 and work that out to be 45 degrees. Now, we don't always do that with diagonals. We don't always look at the angle where they are and split them into 2 equal bits, but we can in a square. Now, I'm not sure whether this reason was actually written in our table, but I'm going to write it down here anyway. So the diagonals in the square bisect its angles. You can check the table, we might have had it written down there. So what it means is the diagonal in the square bisects or cuts into 2 equal bits the angle in the square. Okay, so that's why we're able to divide by 2. So you have to explain why you are dividing by 2. Okay, it's really important that you write your reasons down for every step that you do in geometry. Okay, we're looking at C. So we've defined 2 things here, M and N. So this shape, looking at it, it's got 1 pair of parallel sides, so it's a trapezium. But I'm going to tell you a little bit more about this one. Because it's got 2 equal sides here, which a trapezium doesn't have to have, it's actually called an isosceles trapezium because of those 2 equal sides. You're not going to be expected to know the name of that, but I'm telling you anyway because it may help us. Okay, so if we have a look at this one, we've got a pair of parallel sides here. I'm going to get my red pen and extend those parallel sides out here. And I'm going to extend this transversal here. Because then you're going to see that we can use angles in parallel lines here. So if I have a look at this shape here, this letter M, I'm going to go around that letter M with my pen. And I'm going to go around the 105 degrees with my pen. And you'll see the C shape that's forming. So that means we do have co-interior angles here. co-interior angles, they're not equal to each other, they don't look it, but you know that they add up to 180 degrees. So let's write down that m plus 105 equals 180 degrees. And if we want to find m, we're going to move this to the other side to be minus 105. And that means we're going to have m equals 75 degrees. Now we haven't explained it, we haven't given our reason. So back up here, you've got to explain where the 180 came from, because I didn't give you 180. You've got to tell everybody where that came from. And that came because we knew that co-interior angles add up to 180 degrees in parallel lines. So because you've got the video working, it's probably better if you kind of let it play, and then you probably don't have to squeeze it in like I just did. Okay, so that's m equals 75. I'm going to write that in, because sometimes that helps us get the rest of it out. Now we've got to find what n is. Now, I'm going to help you out here, because if we know that this is an isosceles trapezium, we can jump straight to this answer. So for n, I want you to think about this just logically. If that side is equal to that side, think about it. That angle will have to equal this one. So I'm going to say that n equals 75 degrees. And I'm going to just write, now this is not a reason that anyone really is going to expect you to know, but you've kind of got to explain things still somehow. So we're going to write that it's got equal base angles in isosceles trapezium. Now I'm really extending you here, but you've got to give some sort of a reason. There it is. Okay, so what we're saying is that these are the two equal angles. They're the base angles in an isosceles trapezium. Okay? Or you could say, it's a bit like the isosceles triangle. You could say the equal angles, opposite equal sides. Instead of that. Okay? So you can say equal angles, opposite equal sides in isosceles trapezium. That probably would be better. And there's your answer for that one. So you've got both answers out with the reasons for everything. We're up to D now. So we've got a shape here. It's got two pairs of opposite sides parallel. It's a parallelogram. It's important you identify the shape before we start. All right, now here we've got to find the length of this little side A from here to here. And then we have to find the length of this side K from here to here. Okay, so this is the first one where we're dealing with side lengths and not angles. You can probably just use your common sense here. I hope you can see that A will have to be the same as this one here. So A is going to equal 4 centimetres. Now, how to explain that? Well, you know that this diagonal here is going to split the other diagonal into two equal parts. So that's what we're going to say. Diagonals bisect each other in a parallelogram. And likewise, and you can actually use the word likewise or similarly, right? In the HSC, they'll use the word similarly. It means they don't have to repeat themselves. Not many year 8s are going to know that, but we'll tell you anyway. So we can say similarly, K is going to equal 7 centimetres. Because of similarly, you don't have to repeat your reason, but I'm going to repeat it anyway. Okay, so we're up to the last one over here, E. So if you look at this shape, we're dealing with a rhombus. All four sides are equal. This question's supposed to be hard, so we better see what's hard about it. All right, so if you have a look at it, we're finding some angles in this one. We've got 41 degrees given to us at the top. So what else have we got? Do we have any other angles? Well, if you think about one of the properties of the rhombus, the diagonals bisect each other. So in other words, that will equal that, and that will equal that. But they bisect each other at right angles. So there you go. We've automatically got what P is already. So we can say P equals 90 degrees because the diagonals of a rhombus, make sure you name this shape, bisect each other at right angles. Okay, so now we're back up to A. Now if you have a look up the top here, we've already got a right angle here as well. So now what you're looking at is this little triangle. So if you just look up in the green triangle, we've already got two angles in that triangle, and we're looking for the third angle. So we can say A equals, start with 180 degrees for the angles in the triangle, minus 90, minus 41, work out what's left. And it's 49 degrees. And the reason for that, explain where that 180 came from. It came because we knew the angle sum of the triangle was 180 degrees. So I'm having trouble fitting this in. I'll turn the camera around in a minute. So I'm hoping you can all see that. I'll just turn it around a little bit so you can see it. And that's supposed to be the hardest question. So the other questions shouldn't be too bad. So make sure when you do this question in the homework, it's question, I'll just tell you which question it is. It's number 4 in the exercise. It does not say give reasons, but we're doing it. Okay, so when you do question 4, please give your reasons, because in the exam, you will probably be asked, it's not in the next exam by the way, but in the exam when we do examine it, you will be asked to give reasons. So we need to practice it. Good luck with the homework.